March 7, 1945, in a command bunker 30 kilometers east of the Rhine River, German General Günther Blumentritt received a telephone report that initially made him smile with grim satisfaction. American advance units had reached the western bank of the Rhine at the town of Remagen and had, against all odds, managed to capture the Ludendorff railroad bridge before German engineers could completely destroy it. But Blumentritt wasn't worried. He pulled out a tactical map and studied the situation with the calm of a professional who understood the mathematics of warfare. Yes, the Americans had seized one bridge, but the structure was damaged. It was under constant artillery fire, and German doctrine held that a crossing point could only support a limited flow of troops and vehicles. His staff calculated that even if the Americans managed to hold the bridge, they could move perhaps one division across before German forces could organize a counterattack and either destroy the bridge or contain the bridgehead. Blumentritt issued orders for a deliberate, methodical response. There was no panic in his command post that afternoon, and then, 36 hours later, he received a second report that included a phrase he initially thought was a translation error. An American engineering battalion had constructed a complete tactical bridge across the Rhine, not repaired the captured bridge, but built an entirely new bridge from raw materials in under 3 hours. Blumentritt read the report 3 times, then asked his aide to confirm the numbers. 3 hours? That wasn't possible. The Rhine at Remagen was more than 300 meters wide with a strong current. German military engineering doctrine estimated that bridging such a river, even under ideal peacetime conditions with ample preparation, required a minimum of 4 days. His aide handed him reconnaissance photographs taken that morning, and Blumentritt stared at an image that broke something fundamental in his understanding of how armies functioned. To understand the shock of that moment, we must first understand what German officers had been taught about American engineering capabilities, or rather, the lack thereof. In German military academies, Wehrmacht instructors used American bridge-building attempts from World War I as cautionary case studies in poor planning. Photographs from 1918 showed American engineering units struggling with outdated equipment, suffering from disorganization, and taking days or even weeks to construct crossings that German pioneers could complete in half the time. This wasn't propaganda, it was historical fact documented by neutral observers. American engineering in the First World War had been characterized by enthusiasm without expertise, manpower without methodology. German officers were taught that Americans brought a certain naive optimism to military problems, but lacked the systematic training and precision equipment that characterized European military engineering. When Wehrmacht planners were preparing defensive strategies for the Rhine in 1944, they calculated their response times based on the assumption that American bridging operations would be slow, clumsy, and vulnerable to disruption. A typical entry in German defensive doctrine from that period reads, American bridge construction can be expected to require 4 to 7 days for major river crossings, providing ample time for counterattack preparation and aerial interdiction. This wasn't wishful thinking, it was based on the best historical data available. But that data was 26 years old, and in those 26 years, something extraordinary had happened to American engineering that German intelligence had completely failed to detect. The revolution had begun, not in military camps, but in the civilian economy of the Great Depression. In the 1930s, the United States government had undertaken a series of massive infrastructure projects: the Hoover Dam, the Grand Coulee Dam, the Tennessee Valley Authority, and dozens of major highway bridges. These projects had created an entire generation of construction engineers who had learned to work at speeds and scales that had never been attempted before. The Hoover Dam, for example, required workers to pour more concrete in 2 years than had been used in all previous American dam projects combined. The techniques developed to achieve this, prefabrication, modular construction, assembly line methodology applied to structural engineering had transformed American industrial thinking. When war came in 1941, the U.S. Army Corps of Engineers didn't have to invent new methods. They simply recruited the men who had built the dams and bridges of the Depression era and asked them to apply those same techniques to military problems. The result was a revolution in combat engineering that German intelligence officers, focused on tracking tanks and aircraft production, had entirely missed. The officer corps of the Wehrmacht was aware, in an abstract way, that America had built some impressive dams. But they didn't connect those civilian projects to military capability. In German thinking, there was a firm wall between civilian and military engineering. Civilian projects were accomplished slowly, with unlimited time and resources. Military engineering required speed and functionality under fire, an entirely different skill set. What German planners didn't understand was that American engineers had been training for exactly this kind of rapid construction throughout the 1930s. The Hoover Dam project had operated on penalty clauses that cost contractors $7,000 per day for delays. The Golden Gate Bridge had been built under intense time pressure, with workers operating in dangerous conditions. American civilian construction in the Depression had been military engineering in everything but name, and it had created a vast pool of men who could organize, improvise, and build at speeds that looked impossible on paper. Let us return to that bridge at Remagen and what happened in those 3 hours that shattered German confidence. The American unit was the 291st Engineer Combat Battalion, and when they arrived at the Rhine on the afternoon of March 8th, they brought with them something that looked, to German observers watching through binoculars from the eastern bank, like an enormous pile of metal scrap. These were the components of an M2 treadway bridge, a prefabricated system that had been designed by American engineers using principles borrowed directly from automobile assembly plants. Every component was standardized, interchangeable, and designed to be assembled by men who didn't need to be master craftsmen. They just needed to follow a systematic procedure. The German observers watched with professional curiosity, expecting to see the Americans begin the slow process of surveying the river, calculating load requirements, and preparing foundations. Instead, what they witnessed was something closer to a choreographed performance. The American engineers didn't begin by studying the problem. They began by unloading trucks in a precise sequence, each vehicle arriving at exactly the moment its cargo was needed. Components moved from trucks to assembly positions in a continuous flow. Teams of men worked in rotation, and when one team showed signs of fatigue, a fresh team swapped in without breaking the rhythm of construction. There were no long pauses for officers to consult blueprints or debate methods. The method had already been decided, practiced dozens of times in training camps back in the United States, and refined until every movement was automatic. A German artillery officer, who later became a prisoner of war, was interviewed about what he'd observed through his gun sight that day. He said, "It was like watching a machine construct itself. I kept waiting for them to slow down, to make a mistake, to show confusion. They never did. And the most frightening part was that they weren't rushing. They were simply systematic." 2 hours into the operation, the bridge was more than halfway complete, and that's when the German response finally arrived. Artillery began falling on the construction site, and German commanders were confident this would halt the work. Artillery disrupting bridge construction was a certainty of warfare, as reliable as gravity. Infantry couldn't dig while under bombardment. Tanks couldn't advance through heavy fire, and engineers couldn't build precise structures while shells were exploding nearby. This was doctrine, confirmed by every military experience of the 20th century. Except the American engineers didn't stop. They didn't even slow down significantly. The German gunners watched through their sights as the American engineers simply divided into two groups. One group continued bridge construction while the other group operated in a rotation, taking cover during bombardments and returning to work in the intervals between salvos. They had calculated the artillery timing and built it into their work schedule. This wasn't bravery, it was methodology. They had trained for this exact scenario. 3 hours and 14 minutes after they had begun, the first American Sherman tank rolled across a completed tactical bridge capable of bearing 50 tons, and General Blumentritt's entire defensive timeline collapsed. The bridge his intelligence officers had promised would take 4 days had appeared in 3 hours. The counterattack he had been methodically organizing was still hours away from launching. The airstrikes he had requested were still being coordinated. And in those lost hours, American forces poured across the Rhine in numbers that made containing the bridgehead impossible. By nightfall, more than 8,000 American soldiers were across the river, and 2 more prefabricated bridges were under construction at adjacent sites. The German defensive doctrine for the Rhine, carefully calculated over months of planning, had been rendered obsolete in an afternoon. But the tactical defeat was only part of the shock. The deeper psychological impact came from the implications of what this capability meant. If Americans could build a bridge across the Rhine in 3 hours, how many bridges could they build simultaneously? If they could work through artillery bombardment without breaking rhythm, what would stop them? And most troubling of all, if they could do this with bridges, what other capabilities had German intelligence failed to detect? In command posts across the German Western Front, officers began requesting updated intelligence on American engineering capabilities, and what they discovered was even more disturbing than what they'd witnessed at Remagen. The Americans hadn't just built one type of rapid bridge. They had multiple systems, all prefabricated, all standardized, all designed for assembly by semi-trained personnel in minimum time. They had the M2 treadway for heavy vehicles, the Bailey Bridge system for medium loads, and pontoon bridge systems that could be deployed in under an hour for light traffic. And they had enough of these components stockpiled to bridge every major river in Western Europe simultaneously if needed. Field Marshal Gerd von Rundstedt, who commanded German forces in the West, wrote in a classified report to Berlin, "We calculated our defensive strategy based on the assumption that rivers would delay the Americans. We now understand that rivers do not delay them. They pause, build a bridge with the same industrial efficiency they build tanks, and continue. We have no counter to this. Destroying bridges only works if the enemy cannot replace them faster than you can destroy them." This was a devastating admission, the recognition that Germany's defensive advantages of terrain and river barriers had been neutralized by American industrial methodology. The most haunting assessment came from a post-war interrogation of Colonel Hans von Luck, a respected German tactical commander. When asked what moment made him realize Germany would lose the war, he didn't cite the D-Day invasion or the fall of Berlin. He described watching American engineers building a bridge across the Elbe River in April 1945, while under direct observation from German positions. He said they built it in daylight. They had to know we were watching. They didn't care. That's when I understood we weren't fighting an army. We were fighting a construction company that happened to have soldiers. You can defeat an army. You cannot defeat a nation that can rebuild faster than you can. Destroy. The bridge at Remagen stood for 10 days before the damaged Ludendorff Bridge finally collapsed from the cumulative effects of German demolition attempts, American heavy traffic and artillery damage. But by then it didn't matter. The Americans had constructed 6 additional bridges in the Remagen sector alone, and bridge construction operations were proceeding at more than 30 locations along the Rhine, the river that German planners had believed would be a defensive barrier. For months was crossed and bridged in less than 2 weeks. The military engineering capability that German doctrine had dismissed as slow and amateurish had proven to be faster, more flexible, and more robust than Germany's own vaunted pioneer corps. In the final weeks of the war, a curious phenomenon appeared in German military communications. Orders stopped referring to rivers as defensive obstacles. Terrain that would have been marked on tactical maps as major water barrier, expect enemy delay 4 to 7 days, was now marked simply as water, with no expectation that it would slow the American advance at all. This represented a complete collapse of faith in one of the fundamental principles of defensive warfare. German military doctrine had been built on the understanding that certain obstacles, wide rivers, mountain ranges, fortified cities, could be counted on to impose delays on any attacker, buying time for defenders to regroup and counterattack. But when the obstacle could be neutralized in 3 hours, the entire tactical calculation fell apart. The bridge at Remagen became famous because it was captured intact, a dramatic moment that made headlines. But the truly revolutionary event happened 36 hours later, when American engineers built a new bridge from scratch in 3 hours and demonstrated a capability that changed the fundamental rules of mechanized warfare. It wasn't heroism, though the engineers working under fire were certainly brave. It wasn't luck, though capturing the initial bridge was fortunate. It was systematic, practiced, industrialized competence applied to a military problem, and it was something German military thinking had no framework to anticipate or counter. The German generals, who had spent years studying American military history, reading reports on American training methods, and analyzing American industrial production, had missed the single most important factor. America had spent the Depression building itself into a nation where speed and scale of construction weren't exceptional. They were normal. And when that normality was applied to warfare, what looked impossible was simply Tuesday afternoon.